Hi guys and Assalamualaikum. My name is Eva Natasha binti Mulisin and today I would like to present to you guys about vector calculus and static electric field. Stay tuned. What is vector calculus? So vector calculus is a mathematical tool that helps us to describe how electric field behave in space. It plays an important role in Maxwell equation which form the foundation of electromagnetism. Understanding this concept is very essential because they are widely used in electrical engineering, communication system, and many modern technologies. So, the del operator is the most important operator in vector calculus, which are represented by the symbol nabla. It is used to perform four different mathematical operations, which is the first one is gradient. Gradient is used to tell us the direction where a scalar quantity increases the fastest. The second one is divergence, which measure how much a vector field spreads outward from a point. The third one is curl, which describe how much a vector field rotates around the point. And finally, the Laplacian, which is commonly used to analyze how a field changes in space, and it is very useful in solving many engineering problems. Let's begin with the gradient. Imagine you are hiking up a hill. The gradient tells you which direction is the steepest path upward. In electricity, it shows the direction where electric potential increases the fastest. Next is divergence. Imagine water flowing out of a fountain. The water spreads outward in every direction. A positive divergence means the field is acting like a source, while a negative divergence behaves like a sink where the feed flows inward. Curl measures rotation. A simple example is water spinning around a drain or a tornado. If the curl is zero, it means there is no rotational motion in the field. Now, let's move to electricity. Coulomb law explains the force between two electric charge. There are three important points to remember. First, the charge repel each other while opposite charge attract. Second, the electric force increase when the charge become large. The third one is the force decreases rapidly as the distance between the charge increases because it is inversely proportional to the square of the distance. And this is the law or foundation of electrostatics. Electric field intensity. The electric field describes the force experienced by a unit positive charge placed in an electric field. Instead of calculating the force between every pair of charge, we use the electric field to describe how the surrounding space is affected by a charge. Electric field lines always point away from positive charge and towards negative charge. The closer the field lines are, the stronger the electric field. Another important concept is Gauss' law. It states that the total electric flux through a closed surface depends on the total charge enclosed inside that surface. In simple words, if more charge is enclosed, more electric field lines pass through the surface. Gauss' law is especially useful for objects with symmetrical shapes such as spheres, cylinders, and infinite sheet because it simplifies complicated electric field calculation. Electric potential represents the electric energy available per unit charge. It is measured in volts. You can think of electric potential like the height of a hill. Just as a ball naturally rolls from a higher position to a lower position, positive charge naturally move from a region of higher electric potential to a lower electric potential. A common example is a battery, where current flows because there is a difference in electric potential. Overall, these concepts are not only theoretical but are also applied in many real life technologies. For example, electric fields are used in lightning protection system, electric motors, power transmission, capacitors, communication device, and even medical equipment such as MRI machines. This shows that how vector calculus and electricity play a very important role in modern engineering and also technology. So, in conclusion, vector calculus provide the mathematical tools needed to analyze electric fields. We learn about the dead operator, gradient, divergence, curl, as well as Coulomb's law, electric field, Gauss law, and also electric potential. Together, this concept help us to understand how electric charge interact and form the basis of electromagnetics. Thank you for your attention, and that's all from me, Ifa Natasha binti Mulisin.